This is section 3.1 from the grade 9 textbook Math Links. This is exponents and exploring the meaning of exponential form. Question 1 says, why is it often easier to write an expression as a power rather than repeated multiplication? Use a specific example. So let's say we're talking about a really, really large number like the distance from here to the end of the universe. And let's pretend, I have no idea how, but let's pretend it's this far. And I know it's not that because it's 24 zeros. So 1, 2, 3, 4, 5, 6. I'm off by quite a bit, but let's just pretend it's that. And I don't know what number this is because after a trillion, I don't know what they're called anymore. But this is a lot of zeros. But what we would do is we would use exponential form to write what we call scientific notation. So instead of saying 3, and then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 24 zeros. Actually, I think that's probably pretty close. I would say it's 3 times 1 with 24 zeros. I've lost count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. And that still took a long time. So instead of saying that, what I could do is I could use exponential form to say this is 10 multiplied by itself 24 times. So instead of writing out 24 zeros, I can write exponential form to show this. And what this means is 10 multiplied by itself 24 times, or in standard form, this number right here. In the second example, or second question, question number 3, Pani says when you evaluate a power with a negative base and with an even exponent, you get a positive value. But when you evaluate a positive power with a negative base, and an odd exponent, you get a negative value. Is Pani correct? So she is absolutely correct, because if we think about what this would look like in repeated multiplication, negative 2 is in brackets, which means it is the base, which means it is used in repeated multiplication. So if I write it out as repeated multiplication, I would get this. A negative 2 times a negative 2 is a positive 4. A positive 4 times a negative 2 is a negative 8. And a negative 8 times a negative 2 is a positive 16. So when the base is negative and your exponent is even, the rule is you will always end up with a positive answer because of the rule of the integer laws. And if I look at the same thing when I do it with an odd exponent, so negative 2 multiplied by itself 3 times, I will always end up with a positive being multiplied by a negative, which regardless of what we're looking at, anytime an odd number, we will always have a negative standard form value for that exponential form. Question 4 says write each expression as a power and evaluate. So this is 7 multiplied by itself, not 4 multiplied by itself twice, but 7 multiplied by itself twice, which in standard form is 7 times 7, which is 49. This is 3 multiplied by itself 3 times, which in standard form is, not 9. Took a page right out of someone's book, Evan, which is 27. When I have 8 to the multiplied by itself 5 times, it's 8 to the 5th. Now for this one, we're going to use a calculator. I'm going to show you how to use it properly. So I'm trying to write 8 to the 5th in a calculator. I could go 8 times 8 times 8 times 8 times 8 equals, and get 32,768, 32,768. Or there's a little button right here, XY. So if I put 8 in as my base, and then press this XY button right there, okay? That tells the calculator 8 is my base. And then I say 5, which is telling it it's a 5 exponent, and press equals, I get the same answer, 32,768, without having to do 8 multiplied by itself 5 times. For the next one, I have 1, 2, 3, 4, 5, 6, 7. 10 is being multiplied by itself 7 times. If I grab my calculator and go 10, XY button to tell it's the base is 10 and the exponent is 7, it will tell me 10 million. Now a neat little trick for this is, if you have 10 as a base, whatever your exponent is how many zeros you have in your number in standard form. So 10 to the 7 is 10 million. Question 5, write the expression as a power, identify the base and the exponent of each power, then evaluate. So 1 multiplied by itself 4 times. 1 is the base, 4 is the exponent, and in standard form, 1 multiplied by itself any number of times is a standard form of 1. 2 to the exponent of 5. The base is 2, the exponent is 5. 2 to the exponent of 5 is 2, 4, 8, 16, 32. Again, I could grab my calculator real quick just to double check. 2xy 5 tells me it's 32. 9 to the exponent of 1, 2, 3, 4, 5, 6, 7. 9 is your base, 7 is your exponent. Very important to use it here. 9xy7 equals 4,782,969. I can't even write that down, but you get the idea. And 13, which is a trick question. 13, there are no multiplied by itself, so it's just by itself. So exponential form would be 13 to the exponent of 1. Question 6, evaluate each power. Well, I can do 5 squared pretty easy in my head. It's 25. 3 cubed is 3 times 3 times 3, which is 27. And 4 to the 5, I can't really do easily in my head. So I go 4xy5 is 1,024. Actually, it is easy to do because 4 to the 5 is the same thing as 2 to the 10, if you wanted to do that, but I digress. What is the value of each power? 8 cubed would be 8 times 8 times 8, which would be 64 times 8, which is 480, and 32, which is 512. Rather than, if you're not real sharp at mental math, you go 8xy3. It still tells you 512. 2 to the power of 6. This isn't so hard to do mentally. 2, 4, 8, 16, 32, 64. Grab your calculator, double check. 64. And finally, 1 to any number of exponents is 1 multiplied by itself. Any number of times will have a standard form of 1, not 9. Question number 8 is a table, repeated multiplication. It says, what's the standard form value? So 6 times 6 is 36. 36 times 6 is 216. 3 to the power of 4 is 3 multiplied by itself 4 times, which in standard form is 81. 49 is tricky. And there's a whole lot of things I could show you, but 49 shouldn't be that hard because you know that 7 multiplied by 7 is 49, which means 7 squared is the exponential form. Repeated multiplication for 11 squared would be 11 times 11, and in standard form, most of us know that it's 121. And the last one, 125. Now, I don't have the button on here, so I can't use it, I don't think. Let's just see. Yes, I do. There it is there. So for me, I want to say I know that there is no number multiplied by itself that gets me 125, but there might be a number that when multiplied by itself 3 times, so if I said the square root of 125, I know that when I put that in the calculator, square root of 125 is not, there is no number, so it's not a perfect square, so 125 doesn't work. But however, if I put a 3 up here, it ceases to be what's called a square root and starts to become what's called a cube root. And what a cube root means is what number multiplied by itself 3 times gets you 125. And in your calculator, there is a cube root button. And in mine, I have to press the second function, and it's right up here. It's this button right up here. Okay? So here's what we're going to do. I'm going to first tell it it's a cube root by pressing 3. Then I press my second function, and this, not this, but, oh, Steve Daisy, hang on. This button right here. So what that tells up there, if you read it, it says the third root. The third root of 125, and then press the equals button. Oh, I did that wrong. Shoot. Cubed root. Oh, my heavens. Clear. Try this again. Third root of 125 equals. Oh, I am doing it wrong. Oh, poopy darn. Well, maybe hang on a second. Okay, I know what I'm doing wrong. So listen, you don't put in your 3 first. You put in your 125 first. Then you press your cube root button. Then you tell it you want to know what the cube root of that is. So your y value. And you press equals. And it says 5. This means that 5 times 5 times 5 is 125. So therefore, 5 times 5 times 5 would be the repeated multiplication. And 5 cubed would be your exponential form. Oops. Does 4 cubed equal 3 to the power of 4? Show how you know. Well, the easiest way to do it would be just to find the standard form value of each. Use your calculator. Oh, I'm in second. 4 cubed is 64. So I'm going to put 64 here. And 3 to the power 4 is 3 times 3 times 3 times 3, which I know is 81. So therefore, they do not equal each other. And we just have to say these do not equal each other. Question 10, evaluate each power. So this one says negative 9 squared, which means negative 9, defined as the base because there's brackets around it, multiplied by itself 2 times. Standard form value would be positive 81. Now 1,000 people out of 1,001 people will get the first one wrong on the first try. This does not say negative 5 cubed. What it actually says is the opposite of 5 cubed. If there's no brackets around negative 5, it does not count as your base. 5 is your base. The negative sign that is there, not in brackets, simply means the opposite of. So if I was writing it in repeated multiplication, I would write it like this. 5 cubed is 125. And the opposite of 125 is negative 125. And finally, your last one, negative 2 to the power of 7. Well, if we have an odd exponent to a negative base, we know that our answer is going to be negative because we talked about that already in this question. 2, 4, 8, 16, 32, 64, 128. Your answer in standard form would be negative 128. 11a says, what's the opposite of 8 squared? Since 8 squared is 64, the opposite of that will be negative 64. Now remember, if the question was this would be a completely different answer. That would be positive 64 if that was the question. But this is the question, the opposite of 8 squared, which is negative 64. Negative 1 to the fifth is negative 1 times negative 1 times negative 1 times negative 1. A negative base to an odd exponent is negative. So standard form would be negative 1. And question C says the opposite of negative 3 to the 7. Now, negative 3 is in the brackets, which means it's used in repeated multiplication, but it doesn't really matter for this one because we have an odd exponent. Take your calculator and ask it, what is 3 to the exponent of 7? It will say it is 2187, so I know it's going to be a negative 2187. And this negative sign stays here. What is the opposite of negative 2187? The answer is positive 2187. Copy and complete. Negative 3 cubed is negative 27, a negative base to an odd exponent. Negative 4 squared, a negative base to an even exponent, is positive. Negative 1 in brackets to the exponent of 3 is negative 1. Negative 7 times negative 7, use your brackets because that is what the base is a positive 49. And there are multiple ways you could do the next one. The easiest would be negative 10 in brackets cubed, which would be negative 10 times negative 10 times negative 10. There's multiple answers to that last one, but that's the one you should use. Question 13, does this equal this? No, because this is negative 6 multiplied by itself 4 times. If I take my calculator and go, what is negative, clear. What is 6 multiplied by itself 4 times? It is 1296. This will be a positive because it's a negative base to an even exponent. But this says the opposite of 6 to the exponent of 4, which would be the negative 1296. Without brackets around the negative 6, positive 6 would be the base. And question 16, which we'll stop at, this will be as far as we go today. 1 to the power of 22 in standard form is 1. 3 to the exponent of 4 in standard form is 81. 4 cubed is 64. 2 to the 5 is 32. And 7 squared is 49. Put it in least to greatest. This is the smallest. This is the next smallest. This is the next smallest. This is the next smallest. And this one here would be your largest.